Hello, everybody, and welcome to the Institute for Molecular Science and Engineering's webinar, IMSE for short. Today we're talking about laser cleaning and conservation and historic artifacts. When do you want it? This event is also supported by the Science and Engineering Research for Cultural Heritage Network of Excellence, which is based at Imperial College, and that abbreviation is SEARCH. I'm Anne Barrett. I'm the College Archivist and Corporate Records Manager and part of the SEARCH Steering Committee. All our webinars in this series address science and engineering research for cultural heritage. We'll be putting some helpful links in the chat function, including links to our Eventbrite page, where you can find registration for all our upcoming webinars, the IMSE YouTube channel, where all of our previous webinars are uploaded, our IMSE blog, the Never Lick the Spoon podcast, all our previous briefing papers, and registration to our newsletters so that you can keep up to date with all of our IMSE news and events. Now, just a few top tips. I'm sure many of you will be familiar with this. Just so we can have a great webinar, please make sure your microphone and video are switched off. If you wish to ask a question, please put your question in the Q&A function at any time during the webinar. Your questions will be answered at the end. Please do not put anything in the chat function. If you have any technical difficulties, please message IMSE Imperial privately, and people will try and help wherever possible. So now I'm going to hand over to our presenters for today, Dr. Marina Sokhan and Dr. Michael Paraskos. Dr. Marina Sokhan will be presenting the use of laser cleaning in conservation. Marina is the Head of Conservation Studies at City and Guilds of London Art School and an Imperial College alumnus, having completed her PhD in entitled The Surface Analysis of Laser Cleaned Museum Materials at Imperial in 2006. And her research was conducted in collaboration with the Tate, Victoria and Albert Museum and Natural History Museum. Then Dr. Michael Paraskos will present Historic Artefacts, When Do You Want It? Michael is manager for the Adult Education Programme at Imperial College and a lecturer in art history in the Centre for Languages, Culture and Communications. He also teaches architectural history on the conservation and historic carving degree programmes at City and Guilds of London Art School. I now hand over to Marina.
Hello, so my topic is laser in art conservation, cleaning object of art with infrared. Lasers and conservation is a huge topic. And to talk about this for 20 minutes is just to touch the very much surface. So what I'm going to do, I'm going to discuss laser cleaning using infrared radiation, which is most, let's say, wide used lasers in conservation. The lasers with using infrared radiation used mostly in stone conservation, sculpture conservation, sometimes in gilded surfaces. When we're talking about, for example, painting conservation or conservation of wood conservation or textile or paper, sometimes we use, not sometimes, we mostly use UV lasers. So let's start. Lasers. I'm sure everybody heard the word, and it's light amplification by stimulated emission of radiation. And the laser on the screen, it's laser which used in Victoria and Albert Museum, Tate Gallery, Natural History Museum. The British Museum got more modern version, but the basic of the design is the same. And this laser is able to deliver different kind of the energy density and using two wavelengths, 1064 nanometers and 532. 1064 nanometers, I hope we all remember that it's infrared, and 1064 nanometers, it's near infrared, and 532 nanometers, its visible range, and its green, what we call green color. So what happens when the laser beam hits the surface? The laser beam deliver high density energy, and as a result of interaction, we've got ejection of all kind of particles and we've got all kind of phenomena. So we've got atoms, ions, molecules, clusters, particles, and most important thing, that to achieve the high rate of or efficiency of interaction, we use not continuous wave laser, but we use the Q switch, which means that we deliver portion of energy during the short period of time. Linton lasers, which we use in UK and which who provides the laser to all conservation departments, deliver lasers with a pulse duration up to 10 nanosecond. 10 nanosecond. You can imagine that even with a low power, low energy delivery lasers, we've got very high power. So what happens when the laser beam interacts or hits the surface? As we mentioned before, we've got clusters, ions, atoms, we've got even electrons, but the most important thing that we recognize 3 different ways of interaction. So we've got, when we've got laser radiation hit the materials, we've got 2 different way of ablation. Ablation is the word which we use in laser cleaning, which means ejection of materials. So if we are talking about photothermal ablation, it means that it usually relates to UV lasers. We've got, as a result of this, or photothermal ablation. It means that we are using the infrared lasers. We've got increase of the temperature as a result of this, vaporization and ablation. If we're using photochemical, not if we're using, but if we've got photochemical ablation, in this case, we're using UV lasers who have got radiation, direct bond breaking and volume explosion, and as a result of this, ablation. But in our lasers, Q-switch laser, when we deliver energy in short pulses up to 10 nanoseconds, what we've got? We've got first material excitation, then we've got thermal and not thermal excitation, then we've got volume change, and then as a result of volume change, stress generation, and as a result of this, ablation of materials. So if we look at the diagram, what happens there, then we actually, in laser cleaning, it's obvious that we in any way, it doesn't matter what kind of laser we're using infrared or UV lasers, the mechanism is the same. What the mechanism of a laser cleaning? Why we've got a laser cleaning? Because we've got the surface, on the top surface of on our materials, the material which is absorbing generate, as a result of absorption, it's generated increase of the temperature. Increase of the temperature leads to first stage melting, then it leads to vaporization. As a result of vaporization, we've got cloud of vapor on the top of our surface, but during the laser radiation, this cloud of vapor ionized. Ionized vapor is a plasma. So we've got plasma, we've got completely, or let's say, hundreds of times higher absorption rates than vapor or than solid materials. So as a result, we've got extremely interesting, and it's a huge simplification, but it's interesting mechanism of which leads to the laser cleaning. So we've got first increase of the temperature. Second, we've got melting and vaporization. Third, we've got plasma creation. As soon as we've got plasma creation, plasma absorbs 100 times higher amount of energy than solid or vapor. As a result of this, the plasma increase, the temperature of plasma increase considerably, but at the same time it shield or let's say use as a works as an umbrella on the top of the surface of substrate. So on one side, laser radiation leads to vaporization. On another side, laser radiation leads to plasma creation, which immediately shields the surface. As a result of the increase of the temperature inside of the plasma cloud, and normal, let's say, room temperature outside, as soon as the laser pulse stops, we've got explosion. Difference in the temperature, we've got explosion. During the explosion, we've got generation of stress on the surface. So on top of vaporization of unwanted materials, which absorb the laser radiation, we've got stress on the surface. And when the explosion of the plasma cloud happens on the surface, it leads to ejection, or as we say, ablation of materials. So if we talk about laser ablation mechanism, we can put a list: absorption first, reflection time depending second, thermodynamics, which means melting latency phase change, which means vaporization, plasma ignition, shock wave, stress wave, plasma, laser plasma interaction, plasma radiation, and gas dynamic expansion, which means explosion. How we communicate, what kind of parameters we use for laser cleaning? First of all, we obviously use the type of laser and the wavelengths. The type of laser, it means or it's continuous wave or it's pulsed laser. Pulse laser, coming back to this statement, the pulse laser or Q switch, which is engineering solution for pulsed laser, leads to the high power radiation with the enough low energy delivery. There are other parameters which we use in laser cleaning. It's energy density. In laser cleaning, we call it fluence. Fluence is the energy which divided energy of delivery from the laser, which divided by the area. So this is modern conservation. Modern conservation means that we not just test treatments, we not just test methodology on new materials, how they behave, how they interact with our objects, with our surfaces. We need to prove that in the long-term effect, that in long term, the treatment, our methodologies, our materials are safe for objects, that they mitigate the deteriorated conditions, then they clean, they remove unwanted layer, but they're still safe for the object. So every single conservation research sooner or later leads to the surface analysis or the bulk materials analysis. We've got a lot of technical equipment which we use in conservation, and it's sometimes it's we're talking about surface topography. In this case, we, for example, talking about white light profilometry, or we talk about scanning electron microscopy when we need to see the condition of the surface with highest possible magnification. But in many cases, we're interested not only on topography of materials, we're interested in chemical composition. So I decided to show you one of the instruments which we use, and I spent years in front of it in Imperial College surface analysis lab. It's focused ion beam mass spectrometer, and this instrument able to be used. We're able to use it for surface topography to see what happens after we apply different treatments, and at the same time we can look at the chemical composition of the surface. The only negative side of this instrument and this technique is that it requires sampling, because we are talking about vacuum chamber. So when we look at the analytical technique, so what do we see? First of all, in terms of mass spectrometry, we use ion beam, which we call the probe, hits the sample, and then we've got, let's say, reflection or the data which we manage to get from the probe, which we detect and show using different techniques. This is an example how we analyze materials which we use for the laser cleaning. First as tests, not as routine cleaning. First as a test to make sure that nothing happens with the surface. Surface is not damaged as a result of laser cleaning, and the long-term effect is, let's say, non-existent in laser cleaning. I will talk about this later on a little bit, but right now on the screen we can see the surface of the silver alloy, and it's silver thread before the laser cleaning, and you can see remains of silver sulfate or tarnishing, as it said, and on the right side you can see the same surface from the after radiation. With magnification more than 2,000 times, we can see even remains of the tarnish, remains of the silver sulfate on the surface of silver. But at the same time, you clearly see that there is no damage on the silver surface. The first laser cleaning object which I saw in my life, it was this wonderful bust by Alfred Drury in Victoria Albert Museum. This plaster bust was cleaned by Pedro Gaspar, who is now the head of conservation in Victoria and Albert Museum. And it was amazing experience, and you can see and anybody who dealt with plaster cast, they know that it's highly porous materials, very susceptible to any water solution. So to clean plaster cast, it's an enormously difficult and complicated task. So to use the laser cleaning, you can see results immediately. So the next one of the most famous cases of laser cleaning is Lorenzo Ghiberti's bronze doors, Port del Paradiso, and the technique which was used for cleaning of this door was, let's say, mixed, complex, but it was done by the group of Italian conservation scientists under the Dr. Siama, and you can see how dramatic, how contrast the difference between site which was cleaned by the laser and the site original. Now, this is one of the most important statement in laser cleaning. Why laser cleaning was brought to existence at all? Expensive in terms of equipment, not easily available, at least when it started. So why people start or even consider laser cleaning in consideration? For very simple reason. Because if we use mechanical cleaning, in this case, we basically control of how much we remove depends on the skills of conservators. Second, if we use chemicals, chemical cleaning, as Dr. Siana said, we can't guarantee, we can't give 100% assurance that it stops when we stop using chemicals. So in laser cleaning, we've got completely different story. The laser cleaning takes place as long as laser switched on, as long as we've got a pulse. As soon as we stop the laser or switch off the laser pulse, we stop laser cleaning. So there is no after cleaning, after much effect. On the screen, you can see again the object from Victoria and Albert collection, textile department. It's wool woman riding jacket who was, used maybe one of the first non-sculpture object in Victoria and Albert Museum for laser cleaning, and you can see the quite ugly spot in front of the jacket and after cleaning. This is the cleaning was of silver thread on the wool jacket. So to use chemicals, it's not possible because we've got textile, mechanical cleaning out of question. So what happens, you usually see it in museums collection when you look at some textile with silver threads or silver embroidery object, and they are usually black. And it's only imagination of visitors and conservators and curators how this object is supposed to look at the beginning. So this is how we check that everything is absolutely fine with the silver thread, and most important, that it's absolutely fine everything with the wool inside. When we've done this, project, the next project was the royal banner, and this is a very famous object. This is how the banner used in real world, and the actual object, it was bought by Metropolitan Museums. So we work for this project. Another materials which is absolutely, let's say, one of the most positive example of infrared and green radiation application to conservation. It's ivory. Ivory, again, ivory, the materials who are very susceptible to water. So what happens with ivory object, they usually left as they are. So you can see how dramatic change between the dirty ivory and the clean with the laser. Another example of laser cleaning application. Natural History Museum, we've got huge collection of microfossils. We're talking about 0.5 millimeters altogether. These objects, these fossils were covered by silver paint in 70s to use it for scanning electron microscopy analysis. They were left covered by silver paint, and everybody was sure that we can't do anything about this. So when we apply infrared pulsed laser, you can see the result, and you can see, and these, drops, these drops around, it's actually remains of the silver paint, but the fossil is absolutely clean, and you can see the level of details which we were able to see after laser cleaning. And again, we're talking absolutely undamaged, clean surface. One of the most interesting projects where laser cleaning was applied is cosmetic payment in Westminster Abbey. The cosmetic payment, you might just quick reminder, the history of cosmetic payment, but what relates to us is the huge restoration project which was undertaking starting from 1867 to 1873 by Sir Gilbert Scott. We are not going to discuss how damaging this huge restoration project was for the cosmetic payment. The huge part of the payment were completely restored, not conserved. So in 2008, the conservation team, which I'm glad to report, consists of 100% of our City and Guilds Conservation Department graduates, and started the conservation project. And this is where they started. This is how cosmetic payment looks like before they start. And this is the first test which we try, and you can see that the layer of dirt on the pavement, it's everything. It's the dirt from walking, it's wax, it's some washing liquids, and it's solid. It wasn't touched over 100 years. So you can imagine how thick and how stubborn this layer of dirt was. So we tried first to do the laser cleaning, and you can see the results. But at the beginning, the conservation team was doing mechanical and chemical cleaning, and you can see how they work. And this is how painstakingly it was step by step removing and trying to expose original mortar, original glass, original stone, or production which was done in 19th century. And then we came with a laser. And it's a Westminster Abbey, so we can't stop visitors and we can't stop service. So I walked in the tent, and it was extra entertainment. And I started with the small flowers. And inside of the tent, it looks like this. And this is a result after the laser cleaning. So this is another example. And this is how it looks after laser cleaning at the end of the project. So if we come back at the beginning, why the laser cleaning was employed. And we definitely, as with any other treatment or any other use of materials or equipment, we first of all, we use common sense. Just because you can do it doesn't mean that you should. So coming back, functional principle of the laser, why it's so effective, why it's so positive, and why conservators who work in, particularly in sculpture conservation, and examples is Notre Dame, Amiens Cathedral, Reims Cathedral, a lot of sculpture in Britain, some cleaning on Westminster front and Victorian Albert actually Museum. Why? Because we're dealing with physics law. We've got absorbing layers and we've got reflecting layers. So we are able, with a laser cleaning, if we use infrared, we're able to remove unwanted materials where absorption rate is higher than absorption rate of substrate. So if we're working on plaster cast or marble, or for example, even on gilded surfaces, so everything which is darker than substrate, than materials underneath, is good for laser cleaning. What is other things about laser cleaning, that it's self-stopping materials. It's as soon as laser beam achieve removing of unwanted materials and hit the surface with the low absorption or high reflection rate, it stops. So the laser beam reflected. So we don't need to worry what happens after this, because as a result of reflection, we don't have any after effect after laser radiation. So when we've got materials which we know for sure that will be highly or more absorbing than base materials and substrate materials, which will be reflected materials, we can say that the laser cleaning is safe. So this is why we use laser cleaning. This is why it's popular, and the only limitation for laser cleaning in conservation practice is the high cost of instrument itself. But when we talk high cost of instrument itself, we need to remember that if we, for example, if we try to evaluate the treatment, for example, we need to take into account, for example, materials. We need to take into account time, labor time. So how many days or months or years conservators spending on the project. The efficiency of laser cleaning is much higher. And again, it's self-limiting process. So as soon as we switch off the laser, we stop the treatment. So thank you so much for attention, and I'm happy to now pass to Michael.
Well, I'm going to begin by admitting to being a bit of a killjoy. Sometimes I think the work of being a historian or being an art historian does require you to be a bit of a killjoy. Perhaps that's especially the role of the arts and humanities in an institution like Imperial College, where science and technology and medicine dominate. I think we are here in the humanities to remind people of history, of times when things went right in the past, but also of times when they went wrong, and to remind people that humanity doesn't always behave in the way you might expect or you might want. In other words, we want to raise moral questions, bring in the morality or ethics into this. And to make matters worse, in the humanities, we rarely give definite answers to the questions we raise. We simply say, yes, but. So rather like this gorgeous stained glass window in York that I remember studying as a student many years ago, we aim to be the prick of conscience. Amongst other things that I do at Imperial, I teach architectural history. It's a popular subject, but I also know it can be a bit of a disappointing subject. And every year I take students to see this building located in the Temple area of London, just off Fleet Street. And we discuss how it was founded by the Knights Templar, how it's a rare survivor in England of the early medieval Romanesque style, and how it displays the typical characteristics of that style, like the semicircular windows and so on. We usually start by looking at the building from this angle, and then we move round to the left of your image and we see the gorgeous Romanesque style doorway, the portal. What's not to like, we might think? It's a great building to explain the basic principles of Romanesque architecture. Except then the disappointment comes in. I have to explain that almost none of what we are looking at in this building is original. It's not just that the church has been restored so many times. At various points in its history, it has been modernised, particularly in the 17th century by the great architect Christopher Wren. In fact, Wren's alterations to the church came in for an enormous amount of criticism in the early 19th century. Writing in the Gentleman's Magazine in 1811, an anonymous reviewer wrote that the church was full of odious Wrenian overlays of doorways, windows, entablature and scroll screens. Now, the point about the anonymous writer's article in the Gentleman's Magazine is that it's evidence of how changing taste has changed the church's form from its original medieval appearance to something that was, in the 17th and 18th centuries into the 19th century, something more modern, presumably more modern because it had Baroque classical elements added to the medieval Romanesque elements. By the late 18th century and into the 19th century, these no longer seemed quite so, well, I'm going to say at the moment, modern in inverted commas. Now, the truth is that at that point in 1811, you couldn't really see Temple Church very easily. You can just see it in the background of this etching from 1804. It was surrounded by shops and buildings. Temple wasn't just a place for lawyers in those days. It had a vibrant resident community and shops, pubs, cafes and so on. As a result of that and this new thinking, from 1811 onwards, and continuing well into the 19th century, a process began of clearing the exterior of the building. All the abutting buildings were removed, but alongside that, the additions that Christopher Wren had put into the building, those Baroque embellishments of which the Gentleman's Magazine complained, were largely removed. This work was undertaken by the architect Robert Smirke. He's probably most famous today as the architect of the British Museum. And hence that's the reason why I cannot say to my students that they are looking at a Romanesque building. Smirke was responsible for refacing the entire building in this rather beautiful Bath stone that you can see on the left-hand photograph. That led to the recarving of decorative detailing, such as the nook shafts on the windows. So that in effect, Temple Church is no longer a Romanesque church, it's a Romanesque revival church of the late Georgian period. And the disappointment amongst some students when you tell them that is palpable. In fact, sometimes they're quite vociferous about it. But the point I want to get across is that Smirke clearly had a vision as to what was appropriate for the church, which differed from the opinion of Sir Christopher Wren. And more than this, Smirke's work on the church can be conceived very much as restoration, insofar as it represented an attempt to restore the church to something like its former appearance, whereas Wren's addition to the church were modernising embellishments, attempting to make it look more modern and Baroque. And what is significant about Smirke's restoration is that it was clearly rooted in a belief that the clock should be turned back in terms of the church's history and could be turned back. Out went everything and anything that was 17th and 18th century, in came things that were 12th and 13th century, to the point where the question we might ask is not simply how do you want your church restored, but to when do you want your church restored? Now, this was quite a common practice in the early and mid-19th century. Let me just give you one example because we don't have a lot of time. This is St Nicholas Church in Barfreston in Kent, not far from Dover. This is how it looked in 1813. It was restored in 1839 by Richard Hussey, and you can see how extensive the restoration is. In some ways it looks quite similar, but what I want to point out are these two windows you can see here. These are pointed arched windows. They date from the late 13th or possibly 14th century. Hussey, when he did the restoration, he thought that was too modern, so he took the windows out and replaced them with facsimiles of 12th century windows. So these are Victorian windows pretending to be Romanesque windows, replacing late 13th, possibly 14th century windows. And this idea of restoration was common, as I say, in the early and mid 19th century. Well, back to Temple Church, and in 1840 two new architects were brought in to complete the work started by Robert Smirke. They were Sidney Smirke, who was the younger brother of Robert, and Decimus Burton, you see pictured here. Now, working under the influence of a medieval revival religious movement within the Church of England called the Ecclesiological Society, they continued the process of medievalising Temple Church. So that if you went to look at the church in 1737, or any time really before Sidney Smirke and Decimus Burton started work on it, it would look like this, would have looked like this, not that dissimilar to what it looks like today. But if you had gone to visit it in 1850, just after Smirke and Decimus Burton had finished their restoration work, it would have looked like this. Here's a photograph from 1908 showing Temple Church after they had finished their restoration. Some of you may be familiar with it already if you're a fan of computer games. This is actually the model for the church that's used in Assassin's Creed, which is set, I think, the particular instalment of Assassin's Creed is set in the 1860s. So it's nice to see they did their homework and got the right version of Temple Church. So what had happened? Well, essentially, in following the ecclesiologists' zeal for returning Anglican churches to a medieval appearance, Smirke and Burton rebuilt the missing conical roof onto the church that they presumed it once had. But those presumptions can just be plain wrong. There is no evidence whatsoever that Temple Church ever had a conical roof. They assumed it must have had one because in their medievalising zeal, they thought it should have one. This was not restoration now, this was fabrication. In light of that, the idea of building a giant witch's hat on top of the roof, or as a roof for a medieval church, seems pretty clear cut in terms of contemporary or modern conservation and restoration today. We would assume it's wrong. But it's always worth bearing in mind the lessons of history. The ecclesiologists thought that their methods were sound as well. In fact, they referred to them as being scientific. But let's think about something more recent. Let's get into the 20th century. Let's think about something perhaps a little bit more subtle. Let's think about the cleaning of sculpture. This is the Parthenon in Athens, and as you probably know, it was once decorated with sculptures on the pediment, on the entablature, which were removed by agents working for Lord Elgin in the early 19th century, and those sculptures were brought to Britain, eventually becoming part of the British Museum collection, and here they are in the British Museum in the Duveen Galleries. As sculptures, they seem to represent everything we know, or we think we know, about the ancient Greek world. Their white marble connotes ideas of classical form, ideas of purity, of ideal Platonic beauty. As a result, the assumption might be that any cleaning of the sculptures should be concerned with conserving and maintaining that white, pure marble appearance. And certainly in a cleaning program in the early 20th century, that was the aim. In the late 1930s, you can see here from these photographs, the sculptures were cleaned prior to being installed in the newly built Duveen Galleries. So you see the horse head of Selene here just before cleaning, and here it is on the right hand side after cleaning. These are mechanical cleaning methods that Marina was talking about that were used. Well, the fact or the idea of maintaining the whiteness of the marbles of the Parthenon marbles was seen by the museum throughout the 19th century as being a particular problem. They didn't ever seem to get white enough. In fact, so much so that in the 1850s, the museum brought in the scientist Michael Faraday to see if he could give advice on how the whiteness could be achieved. He wrote, "The examination has made me, of the marbles this is, has made me despair of the possibility of presenting the marbles in the British Museum in that state of whiteness which they originally possessed." Now, a belief in the whiteness of ancient Greek and Roman sculpture was popularised in the 18th century by Johann Joachim Winckelmann, a German art historian. Although it had been gaining ground in Europe since the Renaissance, in that case largely as a way to differentiate pure white classical sculpture from polychromatic medieval sculpture. Now, this idea of Winckelmann and others permeates into the 20th century, and it underpins the 1930s attempts to clean the sculptures prior to their installation in the Devine galleries. Now, that installation into the Devine galleries was a museum project, but Devine himself, Joseph Devine, a wealthy art dealer who paid for the new galleries, seems to have taken a particular personal interest. David Lindsay, who was a trustee of the museum in the 1930s, he said that at the time Devine lectured and harangued us and talked the most hopeless nonsense about cleaning old works of art. I suppose he has destroyed more old masters by over-cleaning than anyone else in the world. And now he told us that all old marbles should be thoroughly cleaned, so thoroughly that he would dip them into acid. Well, thankfully, the museum didn't dip them into acid, but it does seem to have been quite an aggressive cleaning process. And it does seem that Devine was partly to blame. The process was stopped part of the way through when it came to the attention of the senior management in the museum, and they realised that it had the potential to damage these treasures that they had taken and received from Greece. So a museum inquiry was set up to assess the damage. In it, J.F. Sinclair stated that Daniel, the foreman employed by Lord Devine, I mean, that's astonishing, the person paying for the gallery actually employs the foreman, employed by Lord Devine, had pointed out to him that one of the slabs, that's the marbles, chosen for Lord Devine to show in his new gallery was not white enough, and that Holcomb, in charge of the masons, had previously told him to see if he could brighten it up. The slab was, in consequence, re-cleaned. Daniel commended him for getting it whiter. Also told to the Board of Inquiry was the testimony of Richard Barrett, who was the keeper of Western Asiatic Antiquities of the museum. It was reported that Barrett remarks that he had long been puzzled as to why an elderly labourer had been allowed to sit day after day using hammer and chisel to remove lime, stalagmites and wire brushes to remove the golden brown patina from the Parthenon, metopes and frieze slabs, which were solemnly trundled into him one by one. Notice that golden brown patina. Now, I don't want to use this to raise the rightness or wrongness of the cleaning of the marbles in this way. It clearly was wrong, and the British Museum recognised it eventually at the time. My question is, what is being cleaned off the marbles and why? Well, the why is relatively straightforward. As we've heard, at least since the time of Winckelmann, the assumption about Greek sculpture was that it had been left unpainted, white marble, left as white marble. I suspect had laser cleaning been available in the 1930s, it would have undoubtedly been used on the Parthenon marbles, and they might well have ended up much whiter. But what was that non-white surface that the conservators at the time were being asked to remove? Well, in 2009, it was finally proven that the Parthenon marbles were in fact painted. It had long been suspected, and here you can see a reconstruction of the Parthenon in Technicolor. Here you can see a section of the Panathenaic frieze, again part as it is on the left and partly painted as it was imagined to be. It took a very long time to discover this or prove this scientifically. It was actually Giovanni Verri, who was a physicist working at the British Museum's Department of Conservation and Scientific Research, who used a luminescence photographic technique on a section of the marbles to find microscopic traces of paint that are not visible to the human mind. So you can see the belt of iris here shows up as a luminous band there, showing the presence of paint pigment, calcium, copper, silicate, in other words. But it had long been suspected that the marbles might actually have been painted, and when Faraday was brought in the 19th century, he was asked about this question, precisely about this question. And we can see the sort of evidence people were looking at that time by looking at these figures, figures E and F from the East Pediment. If we turn them round, it's this bit at the bottom left-hand corner you should concentrate on, and if I magnify it, it's actually all this line here is thought to be a brush mark. So they were painted. The whiteness that they wanted was not the original colour of the marbles at all. And the suggestion, the possibility, and it has to be said the likelihood of what was being cleaned off at that time was paint, or at least in part paint. So in cleaning the marbles using chisels and wire wool, but also less aggressive methods of the time such as fuller's earth, there is fear that valuable paint traces were mistaken for dirt and cleaned off on the incorrect assumption that the sculptures had originally been white. As in Temple Church, the belief in a mythical past affected conservation and restoration practice. And so on to our own time. Here we have a masterpiece of Christian art, the medieval cathedral in Chartres in France. It has undergone extensive conservation and renovation treatment in the past decade or two, and has run into exactly the same controversies we've seen in relation to Temple Church and the Parthenon marbles earlier. A newspaper report from France, or media report, notes that studies undertaken before the restoration showed that simply by rubbing off layers of accumulated dust, an original 13th century layer applied over the exposed stone was revealed in an exceptionally well preserved state. Well, who can object to that? Doesn't it sound marvellous? You rub off the dust, and what do you end up with? You end up with evidence, or even the manifestation of, it was suggested, 80% of the original 13th century paintwork. Except with that ... the bit I've missed out. Oops, sorry, there we go, the bit I've missed out. What was that dust? Accumulated dust which included the residue of two other coatings, one from the 15th century and one from the 19th century. In other words, the restoration of the interior to a 13th century wall surface meant the destruction of a medieval and a 19th century surface in the process. So somebody in the case of Chartres made a very clear decision to take the cathedral back to some perceived point in the past, namely to a presumed ideal moment in its history when it was completed and in a pristine state. You can see there the before and after, if you like, of the column there, the pier there. If that sounds familiar, it's because it is. The ecclesiologists in the 19th century also had an ideal vision of buildings in the past, and where something did not fit with that ideal, it was removed. And if an aspect of that ideal was missing, it was fabricated. Now, from a historical point of view, this is problematic. First, it's not how cathedrals, or indeed any building, exists. Buildings are not monuments to particular times, they are temporal phenomena that move through time. Even if we accept the deeply problematic notion there was a moment when Chartres was finished and in a pristine state, is it not problematic from an historical perspective to effectively destroy the subsequent physical records of the life of that building? Well, I suppose at least in Chartres there was an attempt to return the cathedral to some perceived point in its actual past, unlike the Parthenon marbles, in which there was a long-standing desire to restore them to a fabricated position that never actually existed. But even that may not be enough to save our consciences. if the ideal of whiteness that has now been abandoned for ancient Greek sculpture in the face of scientific evidence if that's been abandoned in the face of scientific evidence, there are claims that other historical artefacts are still being scrubbed in order to restore them to a state they never possessed. This is St. Paul's Cathedral. It's been cleaned multiple times over the years. In the late 1990s, a 15-year cleaning and restoration programme for the interior began. But unlike the earlier cleaning programmes, it too has run into controversy. The controversy stems from what's being cleaned off the surface. Again, in this case, it is using mechanical means, using EDTA. The surface was covered in a paint, and what has happened in the recent restoration or recent conservation is that that paint surface has been removed, and it's been claimed that this returns the church to a state that Wren, who built it, wanted it to be seen in. The problem with that idea is that the paint that has been removed was applied by Wren in the 17th century, just after the cathedral was completed. So what we have now is a kind of stripped church where we can see the whiteness of the material, the whiteness of the stone, that being presented as Wren's desired finish, and yet we know, and the cathedral authorities admit this, that Wren never allowed the church to be seen in its pristine, unpainted state. He painted the interior a soft grey colour. Well, all of that brings me back to where I started. The when do you want restoration is as important as the why and the how. We can create technology that might be better, safer and more effective than those used in the past. But as human beings, who are fallible after all, we're still faced with decisions as to what it is we select for cleaning, what is selected to be removed in the cleaning process, in other words, what are we going to destroy in that process, and the question of the ethics as to how those decisions are made. And with that, I will finish for today.
Thank you very much to both our speakers. I think what both these talks actually point up is how much we do really need culture and science to meet, and we really do need to discuss the methods we can use and whether we should use them, and what is the best way to preserve buildings. As Michael says, they are living organisms really that we have to use and adapt throughout the centuries. But then we get to the decorative side of things, and what do we think about that, and should it be restored? Again, historians and architectural historians have to look back through that, but we still need the help of science to investigate that type of thing. And also where science and engineering can help is to preserve buildings, as in the Leaning Tower of Pisa, for example. I can't actually see questions in the Q&A, but I think that what is going to happen, because I have to leave, is that IMSE are going to carry on. But I would like to thank you very much, both of you, for very interesting talks. The next talk is on the 27th of May on the theme of spectroscopy and laser cleaning, and will be presented by Dr. Austin Nevin, the Courtauld Institute of Art, and Dr. Reshma Rao, Imperial College, London. So thank you both, from my point of view, for a very interesting talk. And I'll hand you over now to Leah of IMSE.
Thank you.
Hi. So just to remind anyone from the audience, if you do have any questions, then please do put them into the Q&A section. We have a pre-submitted question. And this question is, regarding laser safety, is this an issue for any applications in conservation laser cleaning? And would an eye safety laser cleaning tool be a significant advantage to the sector?
Okay, the health and safety laser cleaning. There are few rules which we have to follow strictly, must follow, is eye protection. And eye protection is highly selective. So eye protection should correspond, the goggles should correspond to wavelengths, which we use with the laser. And the second thing, we need to make sure that the area is protected for people around us, around laser cleaner, so it's not damaging. If you remember the slide where I'm sitting in the tent in the Westminster Abbey, so yes. About effectiveness. Laser cleaning is expensive at the beginning, but very effective and safe way of removing unwanted layers. We clean laser, we use laser for a number of objects. We remove, for example, if we're talking about, Michael was talking about overpaint, we're able to remove overpaint layer by layer with a laser, so to reach the original surface. So now, for example, Linton lasers, they produce portable lasers, which is less powerful, but at the same time, it's very effective. So, and to arrange protection for the public and arrange, obviously, the goggles for conservators, it's not a complicated task. So it's possible. For example, when cathedrals are cleaned with a laser, it's just protection screen on the scaffolding, or when it's done in the gallery, it's protective screen. I hope I answered the question, but I would like to make a note to what Michael was talking about conservation and restoration. The restoration is conservators are basically now in majority of cases are not taught to do restoration. It's strictly speaking, to do restoration, it's against the law. We train conservators and we work as conservators, and in conservation science, it's extremely important point. The history of subject is sacred. The history of subject is the history of object is sacred. What is considered being a history of object, it depends very much on curators and art historians. We are told what we need to preserve. I can give you the example. We were, for example, treating the polychromy plaster cast from William Morris gallery, and it was the plaster cast of William Morris, and it was covered by nasty, awful, absolutely, really awfully looking the dark brown varnish. And when we look at the history of the object, our first proposal was to remove the varnish and to expose the original color scheme, original polychromy surface. But then curators from the William Morris gallery told us that we can't touch this varnish for a very simple reason, because this varnish was applied by personal friend of William Morris after his death. And this brown varnish is a part of the object history. So it doesn't matter what we think about this varnish, and despite the fact that this varnish wasn't original, we still need to preserve it because it's history of the object. So every single conservation project, not a restoration project, conservation project, it's a highly individual, highly complicated, complex project. The conservation scientist or conservators comes first. They do analysis, they analyze the layers, they analyze pigments, media, they analyze restoration. How many conservation projects it's actually to remove the later restoration? So I hope now when we teach future conservators the huge chunk of training during the at the beginning, for example, in our case, it's a first year BA, it's when they learn what means ethic in conservation, what means philosophy and ethic in conservation. So I hope things moving in the right direction to better future.
So there's actually a question about this in the Q&A. I'll spin that links to this. And it says, do you think that works of art should be preserved in their original sort of indigenous state rather than in a sort of like colonizer culture, even if A, they might have this might have happened a long time ago, or B, it may have been of high importance to the colonizer culture?
I'm not sure I understand what colonizer culture means. I mean, are we talking about artifacts that have come from other parts of the world, or are we talking about you know, something like Chartres Cathedral, which is very clearly a Western object? Should they be preserved in their original state? Well, I mean, I think Marina's, you know, answered that. I think in some respects you have to respect the history. I suppose my point is that somebody is always making making a decision. You know, it's not necessarily the conservator; it's an art historian, or it's the architect at St. Paul. Somebody is always making a decision as to what is important, and it's not an objective position. It changes over time. You know, the lessons of history are that what we think of as important now change, and they change for a number of reasons. They change because our knowledge gets better. We now know that there are, you know, Greek sculpture were coloured, so our knowledge is improved. We needed science to prove that. It had always been suspected, but now we've got science that's proven that. But also it changes because our ideology changes, our presumptions, and that's what you see with the ecclesiologists. They you know, they were absolutely adamant that they were conducting scientific research, but really they were ideologically driven, and they were astonishingly successful in terms of their influence. Again, Marina was talking about that pavement at Westminster Abbey. You know, if you want to see you know, the impact of ecclesiological thinking, you know, Westminster Abbey is an excellent place to go, but you can actually go to any parish church in England, medieval parish church, and you will see that they have modified it because they were so persuasive. So, you know, should it be kept in its indigenous state? It cannot be kept in its indigenous state, you know, if I'm reading that meaning right, because time changes it. But in terms of restoration, in terms of conservation, you're absolutely right, Marina, to bring me up on, you know, conflating the terms. In terms of conservation, somebody still has to take a decision and say to the conservator, you keep that varnish or you get rid of that varnish. You keep that surface of Chartres Cathedral because it's 15th century. Think about that. That's a surface that's 600 years old. I mean, that is not something that's been put up in the 1960s. That's gone. It'll never come back. You know, you keep that surface or you don't keep that surface. St. Paul's, you take away what Wren put there or you don't. Somebody has to take that decision. And the job, I think, my job, you know, within the context of what we do, one of my jobs is to make sure people are asking that question and not getting too carried away with what we can do. You know, we can do all sorts of wonderful things and extraordinary things, but is that thing you said, Marina, just because we can doesn't mean we should. You know, that's where I would come in. Yeah. That's why I stole your quotation and put it on my...
I just want to only add to this that conservators, our main concern is to stop deterioration. This is what we're doing. This is our aim, to stop deterioration, to preserve the object. The next stage, the conservation procedure, the structure, it's preparing the treatment proposal. And proposal is submitted to clients. And clients means not necessarily the private person. It could be museums, it could be public gallery, it could be anything. It could be, if we're talking about the church, it could be the parish. But to stop deterioration, to make sure that we mitigate the evidence of deterioration, and it's never 100%. This is why it's ethic philosophy, because it's never 100%. When we talk about reversible conservation, we all understand 100% it's not possible. So what we're doing, we're choosing less of evil. But our aim to stop the work of curators, art historians, is to say what they want to see, how they see the object, how they see historical and cultural context.
Mm-hmm. Thank you very much. So we've got a lot of questions in the Q&A, but because of time, I think we can only go for one more question, unfortunately. So this question is from Jocelyn, and they have asked, is laser cleaning a good way to avoid contaminating archaeological evidence on objects during the cleaning process?
During the laser cleaning, we eject unwanted materials. For example, I worked with archaeological objects and we managed to, let's say, to remove corrosion. If we use the proper technique, we extract ejected, ablated materials, which we can later on analyze. We actually got technique which we immediately analyze chemical composition of injected, ablated materials. So strictly speaking, if we do, we can design the laser cleaning in such a way that we are not contaminating the original site.
Yeah, I mean, the only thing I would add to that is, or maybe it's a question actually for Marina. That non-contamination, that presumably there has to be built into one's thinking. I mean, it would be possible simply to inadvertently, blast off archaeologically relevant pieces of surface area. You have to presumably know what you're not wanting to take off as much as what you are wanting to take off in that sense. I don't know.
So I just wanted to say thank you to both our speakers. I feel like we could speak on this topic for hours and hours to come. And we've had some great discussion and some fantastic questions and such great presentations. Thank you so much. So massive thank you to Marina and Michael for such an informative presentation and also getting through so many questions and for the discussion. So a recording of this webinar will be put onto our IMSE YouTube channel, and you can find the link for this in the chat function. The next webinar in this series will be on the 27th of May at 2 p.m. On the theme of spectroscopy and laser cleaning, and this will be presented by Dr. Austin Nevin and Dr. Rameshma Rao. So thank you so much to both of you again, and I hope that everyone has a wonderful day. Thank you so much. Thank you.